Now we'll go back with our talk. Two quick things to remember, to be remembered. You can vote this talk or other talks if you download the mobile app of a guidebook. You just need to go on our site europython.eu, click on the mobile guide, and then you can vote this talk with opportunity to vote. I say, they deserve it. And the other thing is this evening, when all the talks are done, starting 9 p.m., there is a Google Code Jam, which is aimed to intermediate to advanced user, and it will be fun just to see how good we are and to interact with other people. You may know Google Code Jam is an important competition among programmers, so doing it directly with Google should be quite cool. Okay?
Thank you. Okay, welcome back. Two things. So I hope you enjoyed Joe's introduction. I think it was done very well. Also, I think it showcased a bit what the cloud can do. So this Innovance cloud that we used, the machines that we used, was sort of dimension for 15 participants, and I believe we had like at least twice the number of people here, and it held up reasonably well. So
46 logins at one point.
Yeah, okay, very good. Also, like obviously, thank you to Innovance for providing this machine and making it possible to do the training. Okay, so I talked to some colleagues in the UK. So Rackspace has the closest data center to us is the one in the UK, and so they offered a promo code for your Europython participants. So if you would like to continue playing with an OpenStack cloud, you can go and register with rackspace.co.uk and use this promo code. I believe this will give you like 50 British pound, 50 UK pound, and which is a great way to sort of continue exploring and playing with an OpenStack cloud. Right. Okay, so the talk that follows is a brief intermezzo, a brief excursion into cloud architecture. This is like a highly personal view. So basically, this is the idea is, what do you need to pay attention to in order to survive in the cloud? Okay, so this is the too long didn't read version. Okay, in case somebody drags you out of this room, okay, these are the four sort of main topics I'd like you to remember. Okay, and I sort of try to arrange them so if you can remember damn. Okay, so basically the first letter forms the word damn. Okay. Okay, so decouple your system into independent components. Automate everything. Don't do manual stuff in the cloud. It will bite you. Okay. Measure and monitor everything, all aspects of your system. Okay. And don't ever do anything synchronously in the cloud. Right. So what are some of the things you or people generally want to achieve when deploying systems in the cloud? Okay. So one is a generally interesting property of a system is agility. Okay, so this is why continuous deployment was invented. So you generally want to be in a position to deploy new features or bug fixes to a system frequently. You know, if it need be, even multiple times a day. Okay, scale. Why do people deploy systems in the public cloud? Because they want to achieve scale. So you know. You don't want to worry about your data center being on fire or whatever. You deploy it in public cloud, and if you've done it well, your system will scale up and down, shrink and grow as needed. And last but not least, another desirable property is reliability. Okay, so you want your system to be reliable. Okay, not just in terms of hey, it's up, but also it's performing reasonably well. So I use this term here, quality of service. Okay, so you don't want people to be angry at you and complain about you. So your system should be up and running, should be available, and it should like perform reasonably well. Okay, so these are some of the drivers when you think of your system that you want to deploy in the cloud, and so I want sort of to contrast this with these four principles I had on the first slide. Like how does decoupling, automation, measurement and monitoring, and also asynchronicity contribute towards achieving these objectives. Okay, before I sort of drill down into this, I just want to sort of point to certain things that are a bit different in the cloud than maybe to what you used if you deploy software in your own data center where you control everything. Okay, so it takes a bit of a mind shift if you want to be successful in deploying an application or system into the public cloud. So the first thing to remember is stuff breaks all the time. Okay, so you spin up an instance, a virtual machine, like 3 minutes later it's hung. It doesn't even crash. It just hangs there, doesn't do anything. Okay, and this is not UDC. Like you have like deliberately deployed your application into somebody else's DC, and so you assume a minimum quality of service. But at the same time, you can't just sort of step in and say, oh, I want this, I want that. So you're a bit at a mercy. Yes?
What do you mean by DC?
A data center, sorry.
Oh, okay.
I apologize. Yeah. Okay. Another consideration is so usually like when people deploy stuff in their own on their own infrastructure, okay, they have their own servers, and they tend to treat these servers like pets. Okay, so a pet is is near and dear to our hearts, and if they fall ill or hurt themselves, we sort of nurse them back to good health, whatever. Generally, we take very good care of them, and they're meaningful to us. We like them. Okay, so in the cloud, it's cattle. So cloud instances are like cattle. Okay, so if something goes wrong with a cloud machine, you don't nurse it back to good health. You just kill it ruthlessly. Okay, because you can have 100 more, no big deal. Okay, so don't grow attached to cloud instances. Okay, they're just like cattle. So spin up as many as you need. If you don't need them, just kill them, slaughter them. End of story. Okay. So, and also don't make them individual. Okay, don't bring up a cloud instance and then do expensive manual things to it, which again would make you grow attached to it. Okay, so automate, make it all automated, cookie cutter. Okay, and if you bring it up, it breaks for some reason, just kill it. Doesn't matter. Okay, so with that out of the way, now let's look at some of these aspects. So continuous deployment. So sort of important for a number of reasons. You want to be able to push out new features frequently, and also bug fixes. So how does decoupling help with that? Well, think about decoupling. The decoupling means is you take your system and break it down in sort of self-contained components. Okay, and these components by themselves, they are easier to develop and also to deploy than your entire system. Okay, so ideally, if you need to push a feature, okay, you don't want to redeploy your entire system, but maybe just one or two components, okay, which reduces your risk. Automation, okay, humans break stuff, okay, including me, including you, okay. So you don't want to log onto a box and then do things manually, okay. But what you want to do instead is you want to use something like Chef or Puppet, okay, and have configuration management in place, okay. Test it, have it reviewed by your fellow DevOps engineers or whatever. Okay, so you have a reasonable level of confidence when you push the button and say deploy, and then your instance comes up that everything will just work properly. Okay, so automation, if done properly, will give you reliability in deployment and will give you confidence that you can actually push the deploy button without breaking everything. Okay, measurement and monitoring. Okay. Important, because if you don't measure and monitor your system, you actually don't know what is happening. It's like flying blind. So one of the techniques in sort of webby kind of systems and startup systems is A/B testing. Okay, so if you're building a system and you don't sort of quite right, you don't sort of know what is right, what people will like more. What you can do is you can deploy like two variants of your system. Like one half is variant A, and the other half is variant B in your cloud. Okay. Then you measure and monitor. You obviously need to define metrics. And then you figure out which variant is better, A or B. and you just shut down the instances with B if A is better, and then bring them all up with A. So this in generally makes you much more agile. Okay, so you can react much faster. You're much more nimble. You can figure out what's going on. So automation helps you have reliable deployments, more frequent deployments. Makes you more nimble, more agile. You can push features, bug fixes. You can measure. Or you should always measure and monitor, okay? You can figure out what people like more, again, push and update your system. No synchronous calls. This is a fairly important principle to adhere to, okay? So think about this deployment scenario. So for some reason, so let's say your system consists of 3 components, okay? And so A, B depend on C. A and B depend on component C, and you need to deploy component C, okay? Now, if the interactions between all these components are of asynchronous nature, so let's say you use message queues, so A and B and queue requests to C in a message queue. Well, this allows you to shut down C for a short while and bring it back up without breaking the system, because you buffer the workload in your message queue. Okay, so this is very important. You don't want synchronous calls. Okay, scaling up and down. Again, decoupling is very important, okay, because each component may have sort of special properties when it comes to scaling. Okay, so if you have one component which is more of a number crunching component, okay, you may need to do different things to it to run smoothly and run well. So automation is also important for scaling. You want to automate image building and configuration of VMs. So let's say you need to deploy a new change. So one way to do it is once your change is through the continuous integration system and all the tests pass, you may want to have like a phase where the new code then is baked into a new image. So that image is uploaded to Glance or whatever you use, and all the new virtual machines are spun up from that new image. Okay, so what this allows you to do is basically deploy new code gradually. Okay. Right. Measuring and monitoring is crucial for scaling up and down. So what you want to have is a reasonably realistic measure of load on your system. Whatever constitutes load in your case. Okay, so it can be CPU load, aggregate CPU load on your fleet. It can be number of requests or lag, time to serve a request. So you want to measure and monitor. Okay, and you also want to define some kind of threshold, saying, oh, as soon as the average response time on this fleet is, I don't know, 1.5 seconds, I want the fleet to be increased by 20%. Okay, so you measure, monitor, and you use thresholds and alerts to trigger auto-scaling actions. And again, you don't want to make synchronous calls. Okay, so scaling. For scaling purposes, using something like queues is important. Think of a bunch of workers. Okay, so let's say you're like a kitten photograph upload service. Okay, and so whenever somebody uploads a kitten picture, you need to process the picture to provide it in various like sizes. Okay, so you may have like one group of virtual machines which is just responsible for taking pictures and crunching them and converting them in different formats. Okay, so using something like queuing is important, because if that group is under load, you can use the message queue for a shorter period of time to buffer the work, spin up more instances, and let them eat away the requests that have queued up. Reliability. So again, decoupling is important because components of your system may have different reliability needs and properties. Okay, depending on what you're deploying, you may need to go to some kind of primary, secondary. Let's say in case of a database, you may need to deploy some kind of primary, secondary configuration, etc. So breaking down your system into self-contained components is important for this as well. Automation. Very important for reliability. Remember, it is us who break stuff by doing manual interventions, so you don't want that. Okay. And again, monitoring is super important. I mean, how do you figure out your system is broken if you don't monitor and measure? Okay, so you need to monitor, and you need to have procedures in place that will for recovering from failures. And regarding no synchronous calls, again, short outages. And if you have a good monitoring and failure recovery in place, your outages will be short. So if you have something like message queues, they should buffer like short outages. Okay, so some tools. For decoupling, there are no tools. You obviously need to use your brain to figure out how you want to break down your system. Okay. For automation, I mean, there's plenty of tools there. So you could use Chef, Puppet, and SaltStack, which is all sort of in the configuration management category. If you need for like virtual image customization and specialization are sort of simple and modest, you might want to use Cloud Init, which is like what Joe showed with this customization script. So this is Cloud Init. For Linux images, you can use Cloud Init to do like fairly simple customizations. Okay. When it comes to monitoring and measurement, so there's a couple of sort of newfangled monitoring systems like Zenzu and Riemann. And there's also like the classic Graphite, which allows you to visualize your monitoring data. When it comes to asynchronous interactions, there's ZeroMQ and RabbitMQ, which are both like different kind of flavors of messaging systems. Yeah, and that's really all I had. So, yeah.
Async programming style.
Yes.
Is it possible? So for the async programming style, is it possible to use something like Greenlit to abstract away the async calls?
You could. So I mean, that's a good question. So you can either expose your client code directly to the async nature, or you can wrap it into something which is pseudo asynchronous. Yeah.
Because async code hurts people's brains.
Well, you can use, I believe somebody mentioned Celery.
I've used Celery before.
Yeah. So Celery is sort of nice because it looks like normal Python code, but under the hood it will use messaging and queues. Yeah. So I have good experiences with Celery. We used it before, so it's good. Yeah. All right. I mean, I'm around if you want to discuss some more. Feel free to talk to me. Thanks. Okay, and I believe now it's on to Swift.
Can
Still charge? Yeah.
this should work, right?
It's on.
I love OpenStack. Oh, I was on mic. Sorry.
Are you aware? We should get a coffee break in about a quarter of an hour. Okay. So, okay. So, can go a little further, but if you go too much further, we lose food, drinks, and so on. So it, okay. Say half past 4, and then we have another 2 hours.
So maybe we can bridge these 15 minutes and then have your presentation after the Side.
Hello. Can you hear me? Yes. Okay, so we're going to have a break in 15 minutes, and I know we had a break before, but this one are going to have like goodies and cakes and stuff like that. So you probably don't want to miss it, or you'll be really angry at us. So instead of me listening to my blah blah blah. So I just so until then, I encourage you. Like the cloud is still running. You know those 15 clouds. And I like during this time, so if you want like to still using like the same info that Jogo was using, and kick up a cloud, a server, and installing Deadstack. So Deadstack is the thing of before. It's if you go on that web page, deadstack.org.
It's not Deathstack, it's Deadstack.
Sorry, I'm not really good with Mac, but I use a Mac, so I should need. Yeah, I'm crap, man. I just know storage. That's all I know. So what do you do? Mirror. Yeah, here we go. Mirror. Perfect. Is it mirroring? Apply. Fuck sakes. Allez.
Is this the all your secret passwords?
Yeah, I don't know. It says like apply. It doesn't want to apply the thing. Told him. Alright, fuck it. Sorry, man. So, but anyway, in the meantime, sorry for my language. Sorry for my French. In the meantime, if you want to go on the slides of Jogo, like he was mentioning, and 15 of you kicking a VM and going to Deadstack. Wow.
So the credentials actually aren't on the website version.
Not sure exactly. It's maybe this one.
Is it? Okay.
Right, so that's actually gone when somebody deleted it.
Yeah, somebody tweeted as well. You can.
Well, if somebody, people want help, I'll be happy to help them bring.
Come on, dude. Mirror the display. That's what I'm asking.
If you want, you can go to ca.cloud.com and get into the Horizon dashboard and do it that way. Don't run Deadstack on your local box.
No,
Just run it in advance.
I was going to.
Because it's designed to run in VM and it'll do things you may not want.
So you really want to do that in a VM? I don't know. I think the network is good with all that stuff. So you can do that on your own VM as well. It's not a problem at all. And the only thing is like it's going to use quite a bit of networking, but can cross fingers, or you can use, if it's like too much, we can use those VM on the Cloud. So literally, you need to do like that kind of stuff. Install Ubuntu if you need to, or kick a Ubuntu Cloud, and download Deadstack and cd it, run that command, and we can go for the break, and it would install by itself. Hopefully that would work. It's annoying that it doesn't work. The mirroring. Ah. Hey, here we go. He just tweeted me.
You've been mentioned favorably. So what happens if you don't mirror?
I don't know, it just don't do anything. Should use a Red Hat.
So, I mean, just use it as it is. Can't you bring up the presentation?
No, I can, but I'll need to do like that. And, hello, everyone. Going to get like torticolli at the end. Sonic, sorry. I just don't understand why it doesn't work. It was working before, but yeah. Anyway.
Do you prefer to anticipate the break so that you can work on it?
Yeah. Anyway, like they're doing stuff at this time.
People are busy.
They are busy doing stuff. It's not like I'm leaving. There's a question right there. If you can yell, shout at me.
No, it's not
So this works normally by,
Yeah.
by itself?
So is enough an LXC or what kind of VM do we need?
Say again? Say again?
Is it enough an LXC for a VM?
You can use LXC, yeah, for Deadstack.
Okay.
You can spin up Deadstack on LXC. That's what I mean. It's even better for performances.
Thanks.
Just use your namespace. Yeah.
He's a fan of LXC. Don't care. I'm just a storage dude. We'll just, yeah, that's all right, don't worry. It's, we'll just spin up the Deadstack, going for the break, and after I'll do my presentation.
Some technical support for that if you wish.
Yeah, if you could, if there's somebody who knows this stuff.
Yeah, yeah, sure, if you want. Please. Margherita, se è possibile far venire Dario per un problema con un Mac e con un contenitore, non prende bene, grazie.
You just say, somebody can make a margherita here. We need pizza right now.
No, Margherita is the name of this
Ah, okay.
diploma.
Sorry, I was trying to be cheeky, sorry.
Although Margherita pizza wouldn't be so bad now.
Yeah, yeah.
Always.
Well,
So do you guys eat pizza every
in
day?
the afternoon, in the coffee break, you got a small pizza, so maybe today too we get some chance.
It's so weird. It was working this morning, that's what I mean.
Maybe you can try restarting the match. Maybe that will help.
I'm not used to restarting, but so I can try.
Rebooting with the adapter, that's
Maybe that will help.
Yeah, I don't think I've restarted for the last month or something.
it's about time.
Yeah, that could be it.
Our expert is coming for you.
Emacs. Do I want to do that? Yes, yes. Yeah. Do I want to do that? Yes, yes.
Nice background, man.
Yeah. So how was the conference so far? Did you enjoy it or?
Lunchtime is the best.
Italian food, right?
No, the people.
Oh,
Also the food, but
And the evening as well. Sorry.
good evening.
the food
Yeah, the
wasn't so
food is
bad.
fine. You know, Italian.
Ah,
Lots of salad. My stomach needed it after 3 coffee breaks with cakes, pastry, and so on. Some salad.
make you, yeah,
My body asked for it.
healthy is better, man. Well, I don't know. I'm vegetarian, so
Oh,
I mean, I don't eat much meat or stuff. I think it would work.
Now it will work.
No, it doesn't. No, it doesn't want. Yeah, get the.
What's the? He was asking what's the problem.
It doesn't do like a mirroring of the mirroring.
If you mirroring the monitor.
Ah, ok. Mirroring.
Poi vabbè, il connettore prima gli andava un po' sul giallo ma perché non faceva bene la presa, quindi penso che sia
Ok.
quello aggiustata dovrebbe
Il
durare.
mirroring dovrebbe essere sotto display, no?
Yeah, it should be.
Under displays.
Oh yeah, it's shit. Yeah, that's what I did.
Okay.
Arrangement.
Arrangement, mirror displays.
Ah, here we go. It wasn't working before. I just want to point this out. I just reboot.
Ok.
Jeez, welcome to Windows. I used to use Linux. I would say, like for the last 10 years, I've been using Linux, and now I just switched to Mac because I think I try to be cool. I saw, yeah, I saw the movie of Steve Jobs, and I was so blah about those guys. I even had an iPhone now. What did I become?
He's not so open.
Yeah, true.
He's a storage guy. He gets away with that.
Yeah, storage guy. We are the weird guy. So there is like 3 types: there's virtualization, storage, and networking, and we don't really talk to each other. I mean, You just use my stuff. I give you an API, and we just talk to each other like that. Use an API to talk to me.
That's what APIs are good for.
That's it. It's like as a service. All right. So now maybe. So yeah, I watched the Tour de France as well. So if I'm going to have So did you guys have success with the install or? Yeah? Yeah. You get, is it Deadstack starting or?
Well, it's still installed.
Oh, perfect.
Yeah, the
Cool.
dependencies can be a bit slow if you have also rate, but it's
Yeah, but the network should be pretty fast inside. If you did like on Innovance Cloud, from Innovance, the network should be like super fast. I mean, I think, hopefully. So you're going to install like a proper Deadstack. It's good to. I know it's like like Deadstack is good like to try a cloud, like to try to see how it works. It's not a reference implementation. So basically, it's just what we use for the CI, for example, and it's good for looking like how stuff are supposed to work. So for example, like when you're going to have to finish to install, you can see like all the configuration have been auto-generated. So for Keystone, you can look at like the way it's been configured and the way it's interacting with Swift and stuff like that. So only thing is that by default, Swift is not installing. By default, it's like most Nova stuff because Swift is quite heavy. But we can configure it to make it working only for certain services. So there is some technique for that. That's the way it configures Swift. So usually like when you want like to know how things work, like for example, if you want to try a new service on OpenStack, you just look like the way to configure it for that service for OpenStack. So for example, Silometer, and yeah, hallelujah, and and so it's been a long day, and so you look over configuring for how to configure that. And after you launch Deadstack is going to configure everything like the way it's going to work. And you look at the configuration file, grep everywhere, and after it's pretty easy to read. It's a shell script, Deadstack. So it's for basically designed for sysadmin. It's a very long shell script though. And it has support for Ubuntu by default and Red Hat by default, Fedora, and I think Debian. Is it Debian? I think they just put Debian back. Yeah, they put Debian. Yeah, I think it's one of our guys as well. We are a small company, so I always mention my name. So it's not like Rackspace.
Sure.
Yeah, I used to work for Rackspace 5 years. So when if you look into your Deadstack, there is a file that I don't think it's there by default, but if you create a file after you run your Deadstack, I don't know did you guys run Deadstack already? So if you run Deadstack, if you open a new window, new terminal where it's installing, you're going to see a file that's been created automatically. That's called local RC, and that's where like you're supposed to put like all your local config, and you can customize whatever you want to install, so what we call services. So in this case, I personally do like only the Keystone, MySQL, and Swift, so it's going to install pretty small, because in that case, for now, we're not going to be able to need to install Nova. But you can customize your cloud like that, and you can put different features. So if you want like PostgreSDB instead of MySQL, you can specify stuff. That's what you wanted. So if it's finished, when it's finished, we're going to edit after, but that will be after the break. I think the break is in 3 minutes anyway. Oh yeah, man. Trying to see who's winning the time trial today. So did you guys try OpenStack before? Or was it your first time on OpenStack trying? No? You've been an expert here? You already tried, or is it the first time?
I use it on a daily basis, almost on a daily basis.
Oh, so you know all of that. You just say you have to cheer it as for cheering us. That's good. But yeah, so you're using it. Not like everybody is a newbie. Everyone else, mostly. You looked at it on the internet, and I was like trying. So really, like I would say personally, like the entry points, like to learn, will be the Deadstack. So it's good to have. After I'll show you as well, like how to use the APIs and Swift and. But to be honest, like Swift is much more simple. It's very simple because what you do is like you take a file, get, put, delete options. You put metadata maybe, or you do some fancy stuff like temporary URL. But you don't have to do much more, from an API point of view.
Is it similar in principle to Amazon DynamoDB? Or what's the equivalent?
Of Swift?
Yes.
Oh, S3, yeah.
S3. So
It's exactly the same.
Okay, so what about React then?
It's similar to React.
So
the whole object storage system.
So why do you create? I mean, there's React, for instance,
I
like
think
open
Swift,
source thing.
Swift was before React.
Really?
Yeah, it was
Okay.
like 2008,
Oh.
2007. React was like only 6 months ago, or yeah.
No.
Huh? Was it or not?
It's pretty long project. I'll check it out.
Well, anyway, like I don't know if you have been there this morning at the Swift presentation. I did not. We can talk more. I don't know if we can talk, but it's just it's been like so. It's coming out from Rackspace, Swift. So it was like a CladFiles v1, and there was like a v1 version. After we reprogrammed it like to make it more modular, and it became v2. And the story that NASA came over to Rackspace and Rackspace came to NASA. So they needed like a computer platform, and NASA needed like a storage platform. And they wanted like everything Python. Is React Python? No, it's
Erlang.
Erlang, yeah, that's what. Is it like it's not like a year or two or something? React?
No, React is much older.
It's like, I don't know. Sorry. Yeah. So anyway, like probably maybe if NASA didn't go to React, maybe it's because it wasn't Python. But like having only one technology answering everything is not really good for the thing. So there is like Swift, there is React, there is other stuff as well. I can't remember the name, but they're all good and they all bring like new stuff.
React is a distributed key value store. It's not really.
Oh, is it?
React is just.
Or maybe I confused another one.
React is a distributed key value store. It's not really good at large volumes of data.
Large
I mean, they
blob.
have cask storage, but it is not what it's good at. It's good at replicating, having like so you don't lose data. It's proper replication. It doesn't lose data. It has writes that don't. They're all. You can do writes on all peers. React is very good at what it does, but it's not a large blob store. It's the cask storage add-in lets you do that, but.
Yeah, I think they had like that's why I was saying like 6 months ago, but I think they get open source only in March.
It's open source from the beginning, and this is C as the cluster
Yeah, it's cluster something, which is part of React, cluster management something, which is
okay.
like it used to be commercial product, but then they realized that.
Yeah, no, I'm not trying to bash anything like React or whatever, but I'm just saying that that's the way I thought like was only 6 months ago because I saw the announcement.
I was just asking why. I mean, yeah, if Swift came first, then well, it's really
I don't know if I don't take my word on it. I don't know, but I know that well it was there at that time, and we just redesigned one, but we didn't. Anyway, like the Python thing was like would be a killer. But feel free.
Okay, so the break is upon us. Okay, so the break is 45 minutes. Do you want to take all 45 minutes, or shall we reconvene after half an hour to finish? Half an hour. Okay, so please be back here then at 5 p.m. The break is on now. So back at 5 o'clock, and we'll continue with the Swift part.
It would be awesome.
Okay.
and I did work on pronouncing awesome. Awesome.
Thank you.
Regia, Margherita, abbiamo finito adesso, facciamo il break che durerà soltanto mezz'ora, diprendiamo.
How long do you spend to do a margarita?